Hello friends, and welcome to this session of HCF and LCM. We have already covered and talked about HCF and LCM in our demo videos, but just to revise and understand what we have learned, let's go through LCM and HCF again. So agenda of this session is to define few terms such as factors and multiples, to define a method to find an HCF, and also to find LCM. So let's straight away go to definitions. So there are two definitions which are important here. First of all, what is a factor, right? A number A is said to be a factor of number B if B is divisible by A, right? So let's take an example and understand it. Let's take a number 50, right? And we have to see what are the factors of 50. So any number which can divide 50 perfectly is its factor. So 1 can divide it perfectly, so it's a factor. 2 can divide it perfectly, it's a factor. 4 divide it perfectly? No, it cannot, so it's not a factor. 5 can, 25 can. Similarly, 10 can divide it perfectly, so 10 is also a factor. So these are factors of 50, right? Let's write another number and find the factors. What are the factors of 24? So the factors would be again 1. So 1 is factor of any number, right? The other factor is 24, right? These two are the factors which are always there. One is 1 and other is the number itself. Now, is it divisible by 2? Yes, it is. Is it divisible by 3? Yes, it is. Is it divisible by 4? Yes, it is. 5? No. 6? Yes. 7? No. 8? Yes. 9? No. 10? No. 11? No. 12? Yes. And likewise we keep on finding, and we will see that only these are the factors of 24, right? So this is how we define factors. Now what are multiples? Again, A is said to be multiple of B if A is divisible by B. This simply means that A comes in table of B. If we write a table of B, A should come in that table, right? For example, if we write a table of 3, all these numbers would appear in table of 3, right? So 9999 also appears in table of 3, 300 also appears in table of 3, and all these numbers are divisible by 3, and hence they are called the factors of 3. Sorry, the multiples of 3. So this is how we define multiples. Now to find factors, the most easy way is write a number in its prime form, right? So 60 in its prime form can be written as 60, first of all, can be written as 6 into 10, then 6 can be written as 2 into 3, 10 can be written as 2 into 5, right? Which can be written as 2 square into 3 into 5. So if we have to write the factors of 60, let's begin with 2. So 2 can be factor, 2 square can be factor, right? 2 square is 4. So these are two factors. Now 3 can be factor, and similarly 5 can be factor. Now 2 into 3 can also be a factor, so 6 is a factor. 2 square into 3 is also a factor, so 12 is a factor, right? 2 into 5 is also a factor, 10 is a factor. 2 square into 5 is also a factor, so 20 is a factor, right? 3 into 5 is also a factor, so 15 is a factor. This whole number, which is 60, is also a factor, so 60 is also a factor, and obviously 1 is also the factor. So these are the factors of 60. So here it should be 5, not 4. So this is how we make factors of any number. Now let's go to what is HCF. When we say HCF, we are talking about highest common factor, right? Factor. When we say common, what do we mean? There has to be 2 or more numbers. Only then we can find common factors. So let's take an example and understand what are common factors. So if we take 12 and 18 and write the factors of each. Let's write factors of 12 first. then we'll write factors of 18. So factors of 12 would be 1, right, 2, 3, 4, 6 and 12. You have to just practice that method of writing the factors and you would be very easily able to write the factors. Factors of 18 are 1, 2, 3, 4 is not, 5 is not, 6 is, 7 is not, 8 is not, 9 is, 10 is not, 11 is not, 12 is not, 13, 14, 15, 16, 17, no, 18 is. So these are the factors of 18. So what are the common factors? 1, 2, 3, right, and 6. These are the common factors. What is the smallest common factor? The smallest common factor is 1. So smallest common factor of any 2 or any set of numbers is always 1. But what we are interested in, highest common factor. If you can see here, the highest common factor is what? Highest common factor is 6. So that is called HCF of these two numbers. Now let's write a very systematic way of finding HCF. So if we are given a question to find HCF of these, right, 90, 120 and 150, how do we proceed? First of all, write all of them in their prime forms. So 90 is written as 2 into 3 square into 5. Again you have to practice it to get them perfectly. Then 120 again in the perfect form, 2 cube into 3 into 5, and 150 can be written as 2 into 3 into 5 square. Now here the prime factors which are involved are 2, 3 and 5, right? So write, second step is select the least power of each prime. So the least power of 2 in all these is, here 2 is raised to the power 1, here 2 is raised to the power 3, here 2 is raised to the power 1. The least power is 1, right? Least power of 3 we would see is 1, and least power of 5 is 1. So HCF would be 2 raised to power the least power, 3 raised to power the least power, and 5 raised to power the least power, which is 30. Just notice that while finding the HCF, we are using the least power, not the highest power, right? So for HCF, we would use the least power. Let's take another example to put things in perspective and to clear a little bit doubt which might arise, right? So we have to find a HCF of 24, 36 and 50. 24 written in prime form is 2 cube into 3, 36 is 2 square into 3 square, and 50 is 2 into 5 square, right? So the least power of 2 is what? In 50 we have 1 2, in 24 we have 3 2's, in 36 we have 2 2's. So the least power is 1. What is the least power of 3? Here we have 1 3, here we have 2 3's, here we have 0 3's. So the least power is not 1 but 0, right? So the least power is 0. Similarly, least power of 5 is also 0. And hence our HCF becomes 2 raised to power 1 into 3 raised to power 0 into 5 raised to power 0, which is 2. So HCF is 2 in this case. So the point which I am trying to make is we have to find the least power. So even if 3 is not here, what we did was we multiplied it with 3 raised to power 0, right? We did that. So we multiplied it with 3 raised to power 0, and 0 is the least power of 3 here, right? So that's what we did for HCF. I think this makes finding HCF very easy. Applications we have already covered in a demo video. I think that application part was more than enough to understand HCF and LCM. There would be lots of question in the assignment dealing with LCM and HCF because it's an important topic for as far as our exam is concerned. So as and when you practice, you would understand when to use LCM and when to use HCF, and how to find LCM and HCF in a fast way. Now let's look how to find LCM, right? Again, when we say least common multiple, LCM is least common multiple. Again, the word common is there, which means there should be two or more numbers, at least two numbers should be there. Only then we can find a common multiple. Let's find LCM of 4 and 5, right? So what we do is we write multiples of 4. 4 multiples of 4 are just table of 4. So 4, 8, 12, 16 and so on are multiples of 4. 5, 10, 15, 20 are multiples of 5. So the common multiples here would be 20. Then we would see the next common multiple is 40, then 60 and so on. So these are the common multiples. Which is the smallest of these? 20. So 20 is called the least common multiple and hence it is called LCM. That's what LCM is, nothing fancy. So LCM is the least common multiple. Let's define a straightaway method, a step-by-step method to find LCM. Again we'll take those three numbers only, 90, 120, 150. Write them in their prime forms is step 1. Step 2 is select the highest power of each prime. In HCF we select the least power. Here we are selecting the highest power. The primes here are 2, 3, 5. Highest power of 2 is 3. Highest power of 3 is 2 and highest power of 5 is 2 again. So LCM would be, here it should be LCM not HCF. LCM should be 2 cube into 3 square into 5 square, which is 600. Again let's take second example, which is of 24, 36, 50. So it's again LCM. So we have to find LCM of these. Again writing them in their prime form. Highest power of 3, 2 is 3. Highest power of 3 is 2. Highest power of 5 is 2 again. So LCM is 600. So the important thing which is to be noticed is in LCM we are looking for the highest power, whereas in HCF we are looking for the least power, right? The next important rule which is not mentioned here or which is not mentioned in our agenda is relationship between LCM and HCF of two numbers. So if we are given two numbers A and B, the relationship is very simple. A multiplied by B would be equal to HCF multiplied by LCM. This is a very common identity which might be used in some questions, so you have to keep this in mind and use this in some question if required. So that's it about how to find LCM and HCF in step-by-step manner. If you stick to this method, there are lots of methods. I would share some YouTube videos on how to use the long division method or how to use the bracketed method which we did in class 6 or class 7. But I think this is the most simple method and most foolproof method, right? And since we have defined steps, step 1, step 2, step 3, you would eventually get at right result in almost all the cases. So I would suggest that you stick to this method rather than going for other methods to find LCM and HCF. That's it for now. I think the demo video which talks about LCM and HCF problems is pretty good. You can again go through that video and solve those problems. More of the problems on LCM and HCF would be covered in the assignment sheet, which I hope you would do really well. Thanks for watching this video and all the best for your preparations.